So now we're going to talk about the different functionality that exists within a linked list. Now, I do need to adjust a few things that I stated previously. I misspoke a little bit. I want you to go back to the train analogy for a second. If a train is a linked list and each passenger car in the train is a node, something needs to hold that linked list. That something in reality would be like a train station, for example. And of course, a train station can hold more than one train. Just like our programs can have more than one linked list, just like our programs can have more than one array or regular list. So in reality, we have our driver class. And I misspoke before because I said the driver class maintained the first node, the head node, and that's not actually true. I apologize for that. What the driver class actually holds is an element of the linked list class. Let's just call this list. And it doesn't really know anything about this. So it might have a list, it might have a whole bunch of linked lists, but for our purposes right now, it's just going to have a single item. Now our linked list class, this is where my error was before. The linked list class, it is what's going to hold the head node. So it's going to hold one element, which is the head. It does not know if any other elements exist within that or following that head. It doesn't even, in fact, that head itself might have a value of null, which means the linked list is empty. That is perfectly feasible. And in fact, when you first create your linked list, that's exactly what's going to happen. The linked list itself, like I said, has just the head. Each node maintains a few important pieces of information. So we have our node. It's got all of its cargo. Now that cargo could be one piece of information, two pieces of information, an object, another list, another linked list, an array. It could be anything. So for generically speaking, I'm just going to write down data type cargo. That keeps it general enough. The second piece of information that a node is going to hold is the next node. And then any behaviors following that. So if we drew the interactions between all these classes, we have our black diamond here, and our driver class is going to have one instance of the linked list class. The linked list class is connected to the node class, and again, it only has one instance of the node class. The node class, this is something new that we haven't seen before, actually connects to itself, because a node actually contains another node. It's almost recursive, but not really. Now, how does this interaction work in terms of our numbering? Well, that node is associated with, the next node is associated with exactly one previous node. This node is connected with exactly one node. Now that node might be a value of null, but it is still just one node. This interaction that we see here is essentially the basics of a UML for an entire linked list. Now in your programs, your driver is probably not going to be called driver. It'll be called something like maybe train station, whereas your linked list might be called a train, and your node might be called a passenger car. It depends on what you're building at the time. So let's talk about the different functionality. Let's start at the most base form first of all, and let's talk about the node. What can the node actually do? What are the behaviors of a node? So the behaviors of a node, there's 4 behaviors of a single node. And the most important one is get next. It has no parameters, and it just returns the value of the next node. That value might be null, or it might be another node. It depends. And then set next. What this does is essentially sets the next variable to the value of new node. This is how essentially we add on another element or insert another element into our list later on. And then of course we need to be able to retrieve the cargo. If we can't retrieve the cargo, it's not very useful. So we're going to have, it's going to return some data type, whatever data type the cargo is. And remember, you might have more than one of these accessors if you have more than one piece of cargo. No parameters, and of course we need the modifier for the same thing. set cargo. And we'll keep this general because we don't know what type of cargo it's actually going to be. New cargo. So that's pretty much everything that a node can do. It can get next, set next, get cargo, set cargo. That's it. Nodes are very, very basic. It's just like the the ticket collector going down the train and saying, hey, is there another car? Okay, I'm going to go to that next car and then I'm going to get the cargo from that car. That's all that's really going on here. The real functionality comes in the actual linked list class itself, because that's what we're building. We're building a linked list. We're not just building an individual node. So let's clear out some space here, and let's start analyzing the linked list class. And that's where all the important stuff is actually going to happen. So our linked list class. Again, you would call that maybe train train in our analogy or something else. It depends on what you're building at the time. So the first piece we're going to do is int get count. And of course, that's going to retrieve the number of cars in the actual whole list itself. This is much easier to maintain. So you don't want to actually have to calculate this every time. That would be impressively so. That would run in on time. It's much easier if you just keep track of how many you've added and how many you removed, and keep an overall count. Don't waste the CPU. The next one is void add to tail. What are you going to add? You're going to add a new node. This functionality will literally go through the whole thing until it gets to one that's pointing at null. Then it would set that guy pointing to our new one instead of pointing to null, and this guy would now point at null. That's all it does. It goes through, finds the tail, and sets the tail to point to the new value, the new node. That's it. Nothing complex. Void add to head. Now this one seems like it might be confusing because you have a lot of data following it, but remember, the linked list only knows that the head exists. It doesn't know anything else. Add our new node. So that would be the same thing as saying if this is the head, that would be the exact same thing as saying, okay, here's our new node. Here's our new node, and have it point to what was previously the head, and now set this guy to be the head, and that's gone. So we literally just said we don't have to really do much, just point to what's currently the head, and we're done. And set head equal to that new one. Insert. This one can be a little bit more tricky. With insert, you got to figure out where you're going to be inserting. So let's say node, node, and node, new node. What this functionality will do will scan through the entire linked list until it gets to the node that matches this one. And it says insert the new node right after that node. So it inserts it after. Of course, if it doesn't find that new node, if it doesn't find this node, then that whole thing will fail and it can't insert it. So it wouldn't work. Node, delete, tail. Now with delete tail, we don't need any parameters. Notice that it returns a node though. So it's going to go through until it gets to the tail, and it's going to return that value, but before it returns that value, it's going to cut off the previous connection. So it's going to find really the second last one, and instead of having it point to that last node, you're just going to reassign it to point to null. That essentially is going to break that connection. The garbage collector will come around and collect that old node and throw it away. Of course, you're going to return that node before that occurs. So your last statement in your program should be returning that value. In your subprogram should be returning that value. Similar speaking, we can do delete head. And literally all you have to do for this one is say the current head, the new head is whatever you were pointing to before, and then return that old head. That's it. Nothing complex there. Delete node, delete position. So we're just going to call it delete. And we're going to say int position. This one will scan through the list until it gets to that integer, that almost like an address similar to an array, and it will delete that element if it exists, and of course return it as well. Anytime we delete something, we're going to return it so the programmer can use it if it needs to. Think of it like this: if you had a linked list of cards and it's represented a deck, you want to get that value back, so then you could then store it into somebody's hand because you're trying to deal out cards. Node get node, and this one might be at a specific position, int position. So given a given index, so think this is like 0, 1, 2, 3, and so on and so forth, retrieve that node and return it back to the programmer. That one will work very well with the following one, which is int find. Find will go through the entire linked list until it finds the node that matches that same node given as a parameter, and it will return the integer, which is the position of that node. It doesn't return the actual node itself, just the position. You can then use that in conjunction with the get node to retrieve the actual node itself. Notice that neither of these delete. That is pretty much all the functionality we're looking at when we talk about a linked list as well as a node. The driver class just has a single instance of the list. So in the driver, it might say something like list.getCount or list.addToTail, and it might pass it a new node. And that's how your interactions with the linked list are actually going to work out. And that's everything we need to know.